All right, in this video I'm going to be going over how to make a custom device driver block. So the process is fairly straightforward. For the first part of this separate mini-series, I'm going to create a device driver that will output a sine wave onto our Raspberry Pi. So the templates for creating device drivers can be obtained using the command real-time create driver block driver templates, or you can just go to useful code and copy the driver templates folder. So we're going to just copy this and we're going to move it into the low-level files and spot custom library and resources folder. We're just going to put that here. So if we want to create a block where we feed it a sine wave and it will output the result onto the Raspberry Pi's command prompt or command window, we need to use a sync. So a sync basically takes in a parameter u and then feeds it to a function of your choosing. If you want to get something from a device and have it output into your Simulink diagram, you need a source block. So the way that the sync device driver function basically works is most of this is just headroom. Anything in the properties is going to be an editable parameter in your block. So if you double click your Simulink block, it will be a parameter that you can edit. Then the next important part is this small subsection here under the methods. So this is divided into three smaller sections. So the setup, the step, and the release. So this is basically exactly what it sounds like. So when your Simulink's diagram initializes, it's going to run whatever code you want in here. During each step of your Simulink diagram, it's going to run whatever code is in here. And when you stop your Simulink diagram, it's going to run whatever you want in here. So typically you would put any initialization functions in here, any functions that run for the duration of the experiment in here, and any functions that help close ports or clean up data would go in here. Then we have to define the input properties. So you can do this in two ways. You can either define the number of inputs, so you can have a bunch of separate inputs, or you can set it up to be a matrix as well. So for this this demonstration, I'm only going to have one input, and we're not going to make it a matrix or anything. And yeah, so we can just get started. So inside of the driver templates, you have your source directory and your include directory. You need to have these two for whatever you're doing. So we're going to go to our source, and we're going to create a new CPP file. So we're going to save this as we're going to call it show input source code, so .cpp. And I already have this code written out for this demo. So all this code is going to do is it's going to take in an input u of double value, and it's going to print that value onto the command window in the Raspberry Pi. And one thing we have to make sure we do is we have to change this debugging header, which is remnant from an old code, to match the header we created. So that would be show input underscore header.h, and then we can save that. And that's it for our source code. It's a very simple example. In our include file, we're going to create a new script, and we're going to call it show input underscore header.h. So now we should have show input source and show input header, and the actual code for the header is located here. So the header, no matter what function you're making, always has to start with this include at the very top. And then following that, you want to define any function that you create in your source. So in our source, we have our function called display input, and it has one double, so we have to say display input. So we've got our source and we've got our header. Now we actually have to create our proper driver, which interfaces the C code with Simulink. So we're going to save this under a different name. We're going to call it show input. Whoops. Show input. And then anywhere in this where you see sync, you basically have to change that into the name of the file. So show input. We're going to replace that oh sorry, we're going to find sync and replace it with show input. And that's basically it. Then we have no tunable properties, or we could, just for demonstration, I suppose. So we're going to call this scaling factor equals 1. So now that scaling factor is going to show up in our actual block when we double click on it, which I'll demonstrate later on. We won't have any initialization functions, but we are going to have what we want to evaluate at every step. So we want it to spit out our input to the block at every step. So first we have to add our include. So we have to say coder.c_include show input underscore header dot h, and then we want to actually call our function. So it's coder.ceval display input, and we have one input u. And we want to scale that input u by our scaling factor here. So we're going to say input u, or actually we're going to say scaled u, scaled u is a double, and scaled u is u times obj.scaling factor. So anywhere that you want to access the parameter scaling factor, you have to say object.scaling factor, since that's how it gets passed between functions. So now we have our scaled u, and so we're going to call this scaled u like that. I'm going to save that. We don't have anything that we want to run at the termination of the Simulink diagram, so we can ignore that for now. We have one input, so that's fine. We check for one input, so that's fine. And now we have to actually add, we have to link everything. So we can just copy this here. So this is for include files. So our only include file is show input underscore header dot h. And then we need to add our source files. So this is show input underscore source.c. And that is pretty much all you need to do. It's pretty straightforward. So now we can save this, and we can open up Simulink and just open up a brand new diagram. We're going to start from nothing. So the first thing you want to do is just set this to infinite time, because we just want it to run forever, and give it a name. We're going to call it show input Simulink. So now we have to actually set this up so that it will run on the Raspberry Pi. So we'll go into the model configuration pane, and the first step is to change the solver to a fixed step solver. And it doesn't really matter which one you pick, since there's no dynamics. We're just going to pick ODE4. And we're going to give it a sample time of 0.01 seconds, which is 100 hertz. Then we have to click hardware implementation, and on our drop-down hardware board menu, we pick Raspberry Pi. And it should auto-configure most everything. We then click on target hardware resources, and this is auto-populated for me, but here you would put the IP address of your Raspberry Pi. Then you'd give the username and the password to log into the Raspberry Pi. Under build options, we want to basically set this to build. We don't want it to run. And we're going to save, and it will build this function in this directory that I set up here. The rest of this we don't really care about for now. And then we have to go to code generation. Our language is C++. We're going to save that. And we want to go to report and turn off code report generation. And then just as a sanity check, we'll go to interfaces. This should be set to C++ class. If you want to run this in external mode to visualize something, you need to set this to a non-reusable function, but I'll cover that in another video. So we're pretty much set up here. So we can click OK. And now we have to actually create our Simulink block. So if you type user or Simulink So now we want to add our MATLAB system block, and then we want to link it to our actual device driver function. So we can pick that here. So show input, okay. As you can see, we now have our Simulink block with one input, and if we double click, we've got our scaling factor there. So we want to feed this a sine wave. Now, one thing we have to change, because we want to send it a sine wave, is we have to go to our settings under interface and code generation and allow continuous time. This allows us to use the clock function, which is inherently used in the sine wave block. So now we can save that, and we can click on the build function. And now we just have to wait. This can be a relatively long process depending on the size of the Simulink diagram. But for this particular code, it shouldn't take too long. All right, so it's already done. So now I'm going to log into the Raspberry Pi via VNC interface, which is down here. Basically, it's just connecting over the internet. And if we navigate to the directory I created before, so that would be experiment software, there is our show input Simulink executable. So now we want to run that. So we open up our command window, and we want to navigate to this directory. So that would be cd/home/pi/experiment software. And then you type sudo // and the name of the executable, show input _ simulink.elf. And there we go. We are running our Simulink diagram in real time on the Raspberry Pi. And it's outputting what we'd expect. So now we can quickly check that our scaling factor actually worked. So if I minimize this and I change this to 5, and I build it again, so save and then build, and now if I go back to my Raspberry Pi and I run that executable again, we can see that the magnitude goes up to 5 and -5, which is exactly what I'd expect to see. So we've successfully made our sync block. So in the next video, I'm going to demonstrate how to make use of the source block to get something from the Pi and output it into the Simulink diagram.